Welcome back to the shop and to the channel. A while ago, you might recall, if you're following the channel for any length of time, that I have this DIY DRO project I've been working on. It was invented by a friend of mine in Chicago, Stefano, and I recently added a servo motor controller to the enclosure for the DRO because the DRO can drive a servo, which is what makes it quite unique. And once the DRO and the servo motor are programmed, I can control the servo from the DRO, which makes the use of things like dividing heads and rotary tables a lot more convenient. And I want to move on to the next step of this project today. Now that I have this dividing head a lot cleaner than what it used to be, I feel a little bit more comfortable about trying to figure out how I'm going to take this servo motor and drive this input shaft on the back of the dividing head. Well, I know I want to have a little bit of reduction, gear reduction here, so I've got a 40 tooth and a 30 tooth pulley, one of those belt pulleys that I got off of Amazon. That should give me a little bit more reduction. Now I just need to figure out how I'm going to mount it here. And I think I can use these two mounting holes on the back of the dividing head. Normally these are used for a universal gear train to do differential indexing, but I'm going to take advantage of them and use them as a mounting point for a plate that I designed in Fusion 360 to mount the servo motor to. I found this piece of 6061 on eBay. I'm bringing this thing over to the Bridgeport, and it just so happens that this piece of plate is just a little bit too big for my vise, or should I say my vise is just a little bit too small for this piece of plate by maybe half of an inch. So now I've got to figure out a different way that I can get this thing secured in the vise. Well, I think what I can do is take this jaw off the movable half of the vise and mount it to the other side. And that should allow me to clamp this part in between the outside of the movable jaw and the fixed jaw, I think. Well, I should be able to now mount this piece of plate here between these two jaws. Well, at least I thought I would. Wouldn't you know it, that these cheap Chinese import vices, they don't close all the way. And, well, it looks like I can't close this vise anymore. So the vise is too small in one way, and it's too big in another. I thought about putting the movable jaw back to where it was and then swapping the fixed one around, but you know, all I really need to do is flatten this piece of material. So I think I'm going to come up with a different way. I think if I just put a parallel down here on the top of the flat jaw, kind of use that as a spacer, maybe. That way I don't have to close the jaw all the way. I think this should work. All I really want to do at this point is just to clean up the edges. So I think this setup will be fine. It's not ideal. I think I'll do better in the future, but for now, I'm going to run with this. Well, I don't really care for the job that this end mill is doing, so I'm going to swap this out for something a little bit bigger. With all four edges now cleaned up and squarish, I want to clean up the faces. So I think I want to use my fly cutter on this. I usually get really good results with it. So we'll get this mounted up in the mill and clean up the surfaces of this plate. I made this fly cutter, man, it must be 3 years ago, maybe. And I use it occasionally, but it's really come in handy. I'm going to adjust this. It uses a left-hand lathe tool. I want to adjust this now. So what I would like to do is do one cleanup pass across the entire surface of this plate. So I want to extend this tool out just to make sure it'll go, the entire distance. I think it'll be a little nicer just to have a single pass. I just want to take off the absolute minimum that I need to in order to clean up the surface. And as I start this, I'm only taking off maybe 5/1000ths of an inch off of the face. However, as I move a little bit further along, it doesn't look like it is cleaning up there on the back side. So I am going to pull this back out and raise the knee a little bit and see if I can't get this to clean up in one pass. I shouldn't be taking off enough to where I would have to do multiple passes. So raising the knee a little bit, maybe going an extra 0.10 of an inch is not a big deal. Yeah, this section over here on the left side near the back there is not cleaning up either. So I'm going to back this up again. No sense in continuing all the way across and take off a little bit more. I am noticing that the back end cut is a little bit deeper than I was expecting, telling me that my head's out of tram. But that's a problem for another day. Right now I just want to clean these up. Well, the first pass across as it's starting to cut looks great, but when that trailing cut comes across, man, it really garbages up the finish. This is, very unsatisfying. It may be because it's taking off so little that it's creating the issue, but it is cutting more than it should. It's definitely out of tram, but it's for a mounting plate. I'm not too worried about it. So for now, I think I'm just going to run with it. Nope, I can't deal with that. That is just crap. That front surface looks great, but that tailing cut, man, it is just garbage. Maybe it's something to do with 6061. Maybe it doesn't machine very well. The insert that's in that lathe tool is a ground insert, and it's new. So I know it's sharp. Obviously, it's doing something right on the first cut. It's just that cut coming off the back that's just crap. So, yeah, I can't deal with that. So I'm going to just swap this out for a large 2-flute end mill. It's a 1-inch end mill, and it's just going to take a little bit longer. Yeah, and you'll see the lines that are made, between passes. But oh well, I'd rather live with that than this. And it's not like I dislike this look, if the lines here that are made by the end mill over repeated passes. I just like it when it's perfectly smooth. I think it's the reason why I like the finish on a shaper versus finish on a milling machine. If my shaper could have handled this part, I would have put it in the shaper. But the vise that's on the shaper is smaller than the one that's on the milling machine. With it all nice and cleaned up now, I want to start doing some layout lines. These aren't, like absolutely necessary, but I guess you might want to call them anti-bozo lines. And I'm just going to use a little bit of blue dicum here to flood the area, and then we'll start scoring some lines so I know where these features are supposed to end up. These first two features that I'm laying out are for some slotted holes. This is what this plate will mount to the back of the dividing head with. And the idea of the slot is to give me some adjustability so that I can tighten the belt that goes over the two pulleys. Well, the intersection of these two lines is the start of laying out for where the motor will mount. I need to machine a recess for the motor. There's like a collar around it, and it needs to be sitting below the surface. So I'll need to machine this area here out about 120 thousandths deep. Well, these marks here are where the mounting holes for the motor will end up. They'll end up on this 90 millimeter diameter circle, and I'm just putting these here. So again, little anti-bozo lines. This area here in the center will need to be completely bored out for the servo motor shaft to go through. I learned my lesson on that first exercise with flattening this piece of plate. So I swapped the jaws around. So I put the fixed jaw on the back of it, and that gives me enough room to mount this plate in here. Now it means I'm going to have to change setups here to machine any of the features for the motor mount, but here for at least the mounting slots, I can get to both of those here without any difficulty. All my dimensions are taken from the lower left-hand corner for these two features, so I'm going to use my edge finder to locate that. Well, the two slots are going to be 5/8 of an inch wide and be about 1 1/4 inches so long. So I'll just use a 2-flute 5/8 end mill here, and we'll plunge down at each apex of the slot and then mill out the remainder in between. Moving the table over to what I believe is the correct dimension. But it looks like I misread the dimension or something doing these layouts, because my anti-bozo lines are in the wrong spot. Well, checking the print here, and I got a set of calipers set to the dimension that's on the print, and sure enough, it's where the end mill is and not where the lines are. So yeah, I'm not sure how I managed to screw that up. This is a center cutting end mill, so I'm just going to plunge cut all the way through the plate. I'll move up to the top of the slot and do the same thing. Then finish out by milling out the center section and then traversing the table forward and back to clean up any remnants. I'll do the same thing over here for the other slot. Well, I do want to make these things look at least a little bit nice, so I'm going to chamfer these slots. I've got a single flute chamfer bit here, and we'll just bring this down to one end of the slot. We'll raise the knee up a little bit, and then traverse to the other side and give this slot a nice looking chamfer. I forgot I was going to do these chamfers when I milled the first slot, so I'll move this back over to the first slot and we'll cut the chamfers there. Well, it's really hard to see from this camera angle, but the center of that countersink bit is right over top of the lines that I drew in the dicom. My anti-bozo lines were in the right spot, but somehow I screwed up the dimension when I milled that slot. It's in the wrong place. Somewhere along the lines, I became temporarily dyslexic because I swapped either a decimal point or a couple of numbers or something, but I am a full 400 thousandths or so off of where I'm supposed to be. And yeah, I kind of screwed this up. Yeah, you can kind of see here where that's not going to line up at all. You know, future me thinks that this could have worked out, but present me right now says, no, that's not going to work. Well, I don't want to completely scrap this part because it's the only piece of aluminum I have that's going to work here. So I think I'm just going to have to fix it. Well, I didn't feel like filming it. So off camera, I used my TIG welder, cranked up to 225 amps, and filled that slot with 3 aluminum TIG welding rods, 1/8-inch rods. It took a little bit of time, and boy, did that thing ever get hot. But I filled it all in, and then machined down the surfaces again so they were flat. So now I'm starting over with this first slot. You can see a little bit of discoloration on this plate where the WD-40 that I left on there got too hot and kind of burnt the plate a little bit, but oh well, I don't care about that. But managed to get a full penetration weld here with this aluminum. I'm glad it was aluminum. I think if it was steel, it'd be a little bit harder because not only would it have been more difficult to weld, but also weld gets kind of hard on steel. And with aluminum, it machines just as easily as the parent material. So I'm kind of glad it was aluminum, but I kind of wish I wouldn't have done it in the first place. So I've got the hole completely filled. I'm going to remachine the slot and we'll try this again. With that crisis averted, I can go back to machining the other features. The next is to start machining where the motor is going to mount on this plate. First thing first is I need to locate that center location that I center punched when I was doing the layout lines, using my wiggler to help me locate that spot, and then I'll zero the DRO. First thing I want to do is go ahead and drill the mounting holes for the motor. There are 4 of them on a 90mm diameter circle. So I have the PCD function of the DRO configured to show me the locations for this. And, you know, it's a good thing I did draw these lines, even though they're not all that visible, because when I looked at the blueprint, I saw 45mm. The 45mm was the radius, and the PCD function on the DRO is expecting a diameter, so I have this programmed wrong. So again, I'm kind of glad I put these anti-bozo lines in here, but I have learned that I should pay attention to them. I'm not going to, hopefully not make that same mistake. So I need to reprogram the DRO for 90mm and reset this so I can drill these 4 holes. I am going to power tap these for a 1/4 20 bolt. I think the easiest way for me to machine this recess for the motor is going to be on the lathe, believe it or not. I don't really think using a boring head here will work very well. I don't have a facing head. I used to, but I sold it a long time ago because I didn't think I would really get any use out of it. Now, of course, that I need it, I wish I would have kept it. But what I'm going to do here first is to center drill that center punch mark. Get me back to 0, 0, and that way I can use a dead center in the tailstock of the lathe to help me chuck this thing up. I have my 4-jaw chuck here mounted on the spindle of the lathe. This is my smaller 8-inch chuck, and I think it will barely fit in here. So I'm going to use the live center in the tailstock to kind of find that that center drill that I put in on the Bridgeport. Kind of hold the plate there, see if I can't tighten down these jaws, get them at least close. And then I'll dial it in with an indicator. But first thing I want to do is see if I can't at least get it close doing it this way. I think that turned out really good. I don't think it's going to be off by much. To get it centered up here a little more accurately, I'm going to put a dead center in that center hole and then my live center in the back of the dead center. I will then put a test indicator on the dead center, and then I'll adjust the jaws until that indicator reads the same, or at least close enough all the way around. I wouldn't normally use this kind of an indicator to do this, but it was mounted on my articulating arm and I didn't feel like taking it off and putting on the right one. So close enough is going to be good enough for this. I do have some play, so I'm just going to use this. I'm not off by more than 20, 30 thousandths, I don't think, in any direction, so it shouldn't take me long to get this dialed in. Yeah, I think that's going to be good enough for what I need here. I can be off a few thousandths, not going to be a big deal. I'm more worried about, is this thing going to vibrate too much since it's completely out of balance. But it is aluminum, it's fairly light, so I'm kind of hoping I don't have any serious vibration issues. Well, that's not too bad at all. I am going to keep it running slow just so I don't have any vibration issues. I'm going to start here by drilling a pilot hole in the center here to start that center bore, which needs to be about 1.25 inches in diameter. I'll step up to a larger drill here just to remove the bulk of the material. I'm going to bump up the speed a little bit here. I think it's turning okay, just for use of the boring bar here. This is not a critical dimension. It just needs to be large enough for the shaft to fit through with the key that's on it. I need to machine this recess that the motor has, this little, I don't know what you want to call it, shoulder that's on it. And this is definitely not the right tool for this. And I can tell just by watching this that I didn't make that plate flat on the chuck jaws. Again, not a critical feature, but close enough is going to be good enough. But this is really, really, really the wrong tool to be using to do this, but I don't really have anything else that I think would work. I think if I dug around in toolboxes, I might have been able to find something, but I'm gonna make this work with what I have. It's not ideal, but I think it'll get me to my least desired result. It might be ugly, but I think it'll work. It would have looked even nicer had I not overshot my dimension. Wasn't paying attention and ended up making this part of the recess a lot bigger than it needed to be. Luckily, I noticed at least reasonably in time before I completely scrapped this plate. I really didn't want to start welding this thing up again and re-machining it, so it didn't go too deep, but yeah, I gotta pay a little bit more attention. Unfortunately, this motor won't fit in here all the way because the chuck jaws are in the way. So there's no way for me to test this thing in situ. And I don't trust my dimensions. So I think what I might try is I'm going to loosen 2 of these jaws. And I'm going to remove the plate. I know this is a huge mistake, but I'm going to remove this and do a test fit. If I got to put it back in here, hopefully it won't be too far out of whack, but you know, I've got choices, and this is the one that I made. Well, I have more work to do on this thing, and so I got to put it back in here. And I know it's not going to go back in the exact same spot. And I know this bore is not going to be centered anymore. And I guess I just don't care. It is just a mounting plate for a motor. There's going to be a lot of variability. It's not going to look great because it's got burnt oil all over it. And, you know, the machining hasn't been all that perfect at this point. So right now I'm just going to run with it because I'm also noticing some other issues with this plate that might convince me to start over. I haven't decided to do that yet, but you know, if this is a little bit out of whack, then so be it. Yeah, it is no longer concentric for sure. It's off, not terribly, but it's off enough. But it's not off enough that it's going to actually make a difference. Right now, I just need to smooth up this bore a little bit. And I need to go a little bit deeper. I need to go just 10 thousandths or so deeper in this recess so that the motor sits in there nice and square, at least squarish. Well, according to the depth micrometer, that is deep enough. So I think we can take it back over to the bench and see how the motor fits. Well, it might not be pretty, it might not be perfect, but it does fit. I've got some 1/4 button head screws here that I'll use to mount the motor to the plate. Before I can mount this thing to the back of the dividing head, I need to make some standoffs that are a little less than 2 inches long. So we'll go back over to the lathe and start making those. I have the 6 jaw back on the lathe and a piece of material from the scrap drawer. I'll go ahead and face off this end and then drill a center. The outside dimension of this part is irrelevant. I'm just going to face it off a little bit, get it cleaned up, maybe take it down to an even 1 inch. Well, I hit right at 1 inch. Surface finish isn't terrible, but it's not great either. That's okay. Pull the life center away because I'm going to go ahead and drill this all the way through deep enough to make 2 standoffs. I am starting with a 1/2 inch drill, and I will drill this to a little bit more than 4 inches deep. This material is getting extremely hot to the point that the anchor lube is actually just boiling off. So I'm going to switch over to oil. The pilot hole is complete, so now I can switch over to a finish size of 5/8 inch drill. Rather than try to take that 5/8 inch drill all the way the entire depth here, I'm just going to get it deep enough to give me 1 standoff, and now I'll use my cutoff tool here. We'll line it up with the end of this part, and that thing is like really hot. Just using my scale here to line up the parting tool. I'll zero off my travadial, and we'll move down 1.9 inches. That'll be the length of the standoffs. I'll finish drilling it now the rest of the way and then part off the second one. Well, these parts, I want to go ahead and deburr them, but they got really hot, so I'm going to use some pliers here. I'll remount up each one of the standoffs and make sure that the ID is deburred and to chamfer the OD. Well, I have the standoffs done now. I went up to Ace Hardware and got a couple of 5/8 inch bolts. They did not have cap head screws, but they did have some hex head bolts. So I'll use those at least for now until I can get some proper socket head cap screws. Well, I'm getting one of these started, but for whatever reason, I can't get the second one to start. I'm thinking maybe that the threads in the base of the dividing head might need to be cleaned up. So I'm going to take these out and run a tap through these holes. With a tap now run through those holes, I should have no problems whatsoever getting these bolts in, but this right here just still doesn't want to start. I'm not exactly sure what's going on here. I'll try the other one. Yeah, the other one threads in there just fine. Let me take a look at that bolt. What? This is metric. There was a metric bolt in the same bin with the other 5/8, and I didn't notice. And, well, crap. What else is going to go wrong with this project? Well, the only 5/8 11 bolt I could find in my bucket of bolts is this really long cap screw, and, well, it's too long, so I ended up making a spacer for it so I could thread this thing in here. I do have some cap screws on order, but they're not going to be here until at least next week. But this will at least let me get this thing mounted up on here, see how it's going to work. Before I get too carried away here, let me move this out of the way so I can mount the pulley on the input shaft to the dividing head. I want to make sure that, you know, things are going to line up okay. Well, I can't get the pulley on the servo shaft because the servo shaft has a key in it that I cannot remove, and there's no keyway in the pulley. But kind of looking at this, it looks like I'm pretty close. I'm pretty close. This should be okay. So I think the next thing I need to do is cut the keyway for this pulley so I can get it mounted on the shaft. Well, one way I could do this is with a broach, but I don't have a broach or a broach kit. Another way would be maybe to use a slaughter, but I don't have a slaughter, or the shaper. I really don't have anything set up for the shaper, but I do have this very tiny lathe tool on a boring bar. And I think I can use this perhaps in the Bridgeport and use the Bridgeport as sort of a manual slaughter. I've seen that done before, and I think this will work to cut the keyway. Well, I have that boring bar in a collet, and I've kind of got it lined up on center, and I'm just moving the table over 5/1000ths of an inch or so at a time, and slowly kind of making my way down to about 120 thousandths deep on this keyway, and I think it's about 200 thousandths wide, something like that. I'll measure it here when I get a minute, but we'll just use a little bit of WD-40 on here as a lubricant and just take this slow. Well, I'm running into a little bit of a clearance issue. I've got the keyway approximately to depth, but I need to make it wider. And the boring bar is kind of hitting on the inside bore of the pulley. I can't move it back far enough to make it wide enough in that dimension. So it's got to be even. So I think what I'm going to need to do is clearance the boring bar. And I don't want to take this thing out of the mill, so I'm going to clearance it in place. Well, it made a little bit of a mess, but it works. It's not stupid if it works, right? So I think I can get a little bit more depth here on it, although now I'm looking at this, I don't think I've clearanced it enough. I need to clearance a little bit higher on the bar. I think that should give me enough clearance to cut this thing to the correct width. I need to cut a little bit off of the back side and a little bit off to the front side. When I get around where I think it should be, we'll do a test fit with the motor shaft. I'll keep widening this keyway a little bit here and testing the motor till I get a little bit closer. I think any fine tuning I can do with a file. I don't want to make it too wide where it gets sloppy in there either. A keyway is now fine-tuned to the right size. I can remount the servo motor on this plate and install the pulley. Well, the pulleys line up reasonably well. I'll lock this one here in place on the motor with a set screw. And then try to get the belt installed. Well, finagled getting this belt on, and I'm not really too keen on how this thing is fitting. It's a little loose here, but that's not really the problem. I think the problem really is more that the belt is actually rubbing on one of the standoffs. Might be hard to see from this camera angle, but the back of the belt's rubbing on that standoff, and I think this could potentially be a long-term problem. But I think I know what I can do to resolve that. But I've got another issue to deal with first. This larger pulley has a keyway already, and there's a keyway in the input shaft. But what I don't have is a key. I have a key that's the right size for the pulley, but it is too wide to go in the input shaft. So I'm going to take this piece of key stock over the bridge port, and I'll narrow in one end of it. I'll do that off camera. We'll have a freshly machined key here, a little narrower on one end to fit in the input shaft, and then left it wide for the pulley. So I'll get this pulley remounted on here, and then get the motor and everything back on the back of the dividing head. Well, I am mounting this thing on the back of this a little bit differently than I have before, and that's I'm not worried about this plate being level with the world. I'm actually tilting it, biasing it a little clockwise, and what that does is it gives me a little bit more tension on the belt, but it also moves that belt away from that standoff, so it's no longer rubbing on the standoff. I think this works out a little bit better. I think had I thought about this, I might have considered even putting this slot maybe on a curve. Give me a little bit more adjustability, but I think for now, I think this will work. I'm not sure if I'm going to remake this plate or not, but if I do, I'll have a lot of lessons that I learned from here. Okay, well, there it is. It is mounted up. The belt is reasonably tight. It's not too tight. I do need to get those socket head cap screws in. Hopefully they'll be in next week, but I think this video has gotten long enough, and I still have to do some math to try to figure out how to program the DRO so that I get the proper rotation gear ratio here for this thing. So there's still quite a bit left to do. Hopefully in the next video, when I do another video on this, I'll have something interesting to show. Maybe we'll make something. I don't know what that will be, but we'll look at trying to make something. But for now, I think that's going to do it for this video. This was actually a lot more work than I expected it to be. Well, this project was certainly full of some problems, some bozos, things that I could have prevented had I been paying a little bit more attention. But in the end, it seems to be working out. We'll know for sure when I get it mounted up and plugged into the DRO. But if you like the video, please give it a thumbs up. Drop me a comment down below. Let me know what you think. What would you have done differently? If I do end up remaking these things, some of your comments might actually be some ideas that I introduced. So don't be afraid to let me know what you think. And a special thank you to all those subscribers that subscribe to the channel. It costs nothing to subscribe. If you do want to support the channel monetarily, you can do that through PayPal or Patreon or even through channel memberships. But I do appreciate everybody that watches, whether you're a subscriber or not. It's a lot of fun to see how many people are watching these videos that, quite honestly, half the time I don't think anybody would even care. But if I don't stop talking, I'm never going to get this video edited and uploaded to YouTube so you can watch it. Thanks for watching, and we'll see you on the next one.